Hello everyone, welcome back. We are going to discuss today the third problem of circles. Okay, already we have discussed two important problems. Now it's going to be the third important problem. Okay, what it says: two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that PTQ equal to 2 times OPQ. Okay, it's a question. Sometimes what happens, they will not give you figure. Okay, they will give only question, so you need to think and draw the figure. Okay, so now presently we have a diagram here, so we will compare it with that. See, TP and TQ are the tangents drawn from the external points, correct? That means what? External point, correct? That means T is a point which is outside the circle. From here two tangents are drawn, that is TP and TQ. Okay, then prove that PTQ. So PTQ means it is an angle between the tangent. Okay, where is OPQ then? See, this is the main thing here, because when you read the first half of the statement and when you draw it, we usually don't have these lines, correct? But when you go to the thing what we need to prove, there only will come to know that there is a OPQ. So OPQ is an angle. So how do you draw it? Start from the point O, draw one line till P. From the point P, draw one line Q. That means OPQ is an angle. So you have to show that this angle is 2 times this angle. That means this angle is smaller angle, this is a bigger angle. So 2 times of this angle will be equal to this angle. Okay. And try to remember this result. Only this result, based on this result, they can ask you a multiple choice question also. It's a very simple if you remember it. Otherwise, we have to prove and check. Okay. Yeah. Let's go to the proof now. So this is a figure which I already marked things which I'm going to use it over here. Okay. So let us write it. What is that? Given TP and TQ are drawn to circle with center O, correct? That means TP and TQ are the tangents drawn from a point T. What I need to prove? The angle PTQ is equal to 2 times angle OPQ. That's what I need to prove. So here no extra construction we are doing, and we are going for the proof now. Okay. In the proof, we are going to prove by taking three concepts. One is theorem 10.2, which says tangents from the external points are equal. Second is the concept of isosceles triangle, because in triangle TPQ, TP and TQ are equal, so two angles will be equal. Okay. Then we are going to take a concept of theorem 10.1, that is radius is perpendicular to the tangent. Okay, one by one we will use now. Now presently we are going to take theorem 10.2. As per that, TP equal to TQ, tangent from the external points are equal. Okay, so when I say TP and TQ are equal, the triangle PTQ becomes an isosceles triangle, correct? When you say it's an isosceles triangle, we are going to get two angles, that is TPQ and TQP. There, can you see this? TPQ and TQP, this blue highlighted angles are equal. So I'm going to consider those angles as x. Okay, you can use TPQ and TQP also, but considering it as a variable, it will give you more clarity that they are nothing but they are equal, because they represent same variable. Okay, so then what I'm going to do is I'm going to take a concept of angle sum property. What is angle sum property? When I add all the three angles of the triangle, I will get 180, correct? So as per that, PTQ means this angle plus x will give me how much? 180 degree. So already I know there is 2 x's, so I'll write it as angle PTQ plus 2x is equal to 180. Then we'll transpose this to x other side. So this is plus 2x becomes minus 2x. Okay, we keep this as equation 1. Now remember, we need to replace x. Okay, in place of x, what I need OPQ. So for that, we are going to take theorem 10.1. What does it say? Since radius is perpendicular to the tangent, means radius is always perpendicular to tangent when it is drawn to point of contact to the center. Okay, so OP perpendicular to TP. So by this what I can say is, see here angle OPT, can you see angle OPT? O to P, P to T means OPT means this particular angle, correct? So this angle is 90 degree. Why? Because OP perpendicular to TP. Okay, so once when you say that, okay, once when you say these two are 90, okay, it has two angles in it. Can you see? One is OPQ angle, another is X, correct? So X plus angle OPQ will give me 90. Right, because OPT contains two angles, a blue angle and a red angle. So when I add blue and red angle together, That means x and angle OPQ together, I will get 90. So then what I'll do, I'll transpose OPQ this side. Why I'm transposing OPQ only this side? Because x I need to replace, correct? Because in the first equation we have an x here, right? This x needs to be replaced. So I'm going to use the second equation in the first equation. That means substituting equation 2 in equation 1. So when you do that, what happens? In place of x, correct? I'm going to put what? See here, 90 minus OPQ, right? See, in place of x I have written 90 minus OPQ, right? So now we are going to open the bracket. That means we are going to multiply 2 into 90 and 2 into angle OPQ. So main thing is negative sign, okay? So when you multiply that way, so what happens? See, that negative sign becomes a positive sign. You can notice this, right? So when you multiply 2 into minus OPQ, minus 2 into minus OPQ becomes plus 2 angle OPQ. Now it's very clear that 180 we can cancel, correct? How we can cancel? Because this is plus 180 and minus 180 becomes 0. So you can just show it as a cancellation. So what do we got? Angle PTQ is equal to 2 angle OPQ. So this is what we need to prove. Hence this problem is done. Okay. Thank you.